Students, this is 81st Maths class. Look at that, students. There is a question on the board. I have written a question on the board. Same type question, same type question has been solved in that previous video. So go for solving. So you can able to solve this question, students. So you go for solving that. Solution. Let fx1 is equal to fx2. Let fx1 is equal to fx2. That implies fx1 means 9x1 square plus 6x1 minus 5. fx2. So 9x2 square plus 6x2 minus 5. Minus 5 get cancels. Bring these terms left side, students. 9x1 square minus 9x2 square plus 6x1 minus 6x2 0. Tell me what is common from these two, students. 9 is common. x1 square minus x2 square. Tell me common from these two. 6. x1 minus x2 0. You see this, students. A square minus b square. What is a square minus b square? A plus b into a minus b. 9 into x1 plus x2 into what? x1 minus x2 plus 6 into x1 minus x2. You see this full equation, students. You see this full equation. There is a common from that full equation. Tell me that common. x1 minus x2. x1 minus x2. It is there in both the terms. Means it should be common. Remove that common and put it outside. So write x1 minus x2. So if this x1 minus x2 is removed, if it's been removed, tell me remaining of this term. So what remains in this term is 9 into this quantity. So if I remove x1 minus x2, the remaining will be 9 into x1 plus x2. Multiply by 9. 9x1 plus 9x2. Again, from the second term, if x1 minus x2 is removed, if it is being removed, the remaining will be 6. Again, as usual, make this as not equal to 0. So make this as equal to 0. Because our intention is to get x1 is equal to x2. So 9x1 has 9x1 plus 9x2 plus 6 not equal to 0. That implies x1 minus x2 equals 0. Now, so from this x1 equals x2, therefore f is 1, 1. F is 1, 1. Now on to as usual, let small y belongs to, so what is second set? Minus 5 to infinity. Be any element. That implies, so write y equals fx. That implies small y equals, what is fx? 9x square plus 6x minus 5. Again, you write 9x square as 3x whole square. Small y equals 3x whole square plus 6x plus 5. You take this as a square. This becomes 2ab. B square required. To get a plus b whole square formula, b square required. You observe, students, how I calculate b value. In the place of 2ab, I am having 6x. 2ab is equal to 6x. 2 into, substitute for a. A square is this much. A value 3x into b is equal to 6x. 3 2s 6x. 6x get cancels. B is equal to 1. If b is 1, b square equals 1. You go for adding and subtracting. Small y equals 3x whole square plus 6x a square plus 2ab plus b square. Tell me b square. 1 minus b square plus 5. Add 1, subtract 1. Add 1, subtract 1. A square plus 2ab plus b square plus b square. Now it is a plus b whole square. 3x plus a. A means 3x. B means 1. 3x plus 1 whole square. 3x plus 1 whole square. So 3x plus 1 whole square. This is minus 5, students. Minus 5. Carry that minus 5. Minus 5. Minus 5. Right? A plus b whole square. 3x plus 1 whole square. Minus 1 minus 5. Minus 6. Minus 6. Now calculate x value. Onto means finding x value. You find out x value. So that is small y. Small y plus 6 is equal to 3x plus 1 whole square. Bring the square this side, becomes root. So root of y plus 6 is equal to 3x plus 1. Calculate x from that. So root of y plus 6 minus 1 is equal to 3x. From this, tell me x root of y plus 6 minus 1 by 3. By 3, correct? By 3. Root of y plus 6 plus 1 this side minus 1 3x by 3. Belongs to first set. Belongs to first set. Tell me first set, students. R plus. Therefore, f is on to. That implies f is bijective. F inverse exists. To find f inverse. As usual, tell me y value, friends. Y is equal to 9x1 plus 6x minus 5. From that, tell me x value. X is equal to root of y plus 6 minus 1 by 3. Belongs to, no, not right. Therefore, f inverse y is root y plus 6 minus 1 by 3. Or f inverse x is root x plus 6 minus 1 by 3. We got f inverse x, students. Let us go for solving one more simple question. So write if one more question. If fx equals 4x plus 3 by 6x minus 4. So write, show that x is not equal to 2 by 3. Show that of x equals x, comma, what is the inverse of f? What is the inverse of f? Solution. You prove that of x equals x. Show that you know how to find pop. In the last class you learned that pop x. Circle means into f into fx. Circle means into. Circle means into. Substitute for fx. What is fx? So that is f of fx means 4x plus 3 by 6x minus 4. Now you substitute, you put this quantity in f, that is put x equals 4x plus 3 by 6x minus 4 in f. In f, this you know very well, we have solved so many problems of this type. Put this quantity in f, where that f is, here is f. In the place of x, go on writing that quantity. You write that, put x is equal to, right? You solve, we have solved this type of problems. Put this in f. Putting this in f means this is f. In the place of x, you write this much. Right? 4 into, what is x value? 4x plus 3 by 6x minus 4 plus 3 by, so 6 into, what is x value? 4x plus 3 by 6x minus 4. And you find out LCM and simplify, students. Find LCM and simplify. So what is LCM? The LCM of these two is 6x minus 4. 6x minus 4. 6x minus 4. Cross multiply. 1 into 4, 4. 4 into 4x plus 3. Plus 3 into this. 3 into 6x minus 4. Come down, you come to denominator. Again, what is LCM? 6x minus 4. Cross multiply. 1 into 6 into 4x plus 3. This side, minus 4 into 6x minus 4. So these two get cancelled. Simplify that. So write 4 4s are 16x plus 4 3s are 12 plus 6 3s are 18x minus 4 3s are 12 divided by, come to denominator, 6 4s are 24x plus 6 3s are 18. So minus 6 4s are 24x minus into minus plus 4 4s are 16. Look at this, students. Plus 12 minus 12 get cancels. 16 plus 18, 34. Is that 34 correct? Right. Next, 24x by 34 get cancels. We got it. Of x equals x. Of x equals x. You know this very well. Of is identity function. If we have same x on both sides, it is identity function. Just like that. It is just like fx equals x. Fx equals x. So identity functions are self-invertible. If f is identity function, inverse of f is itself. I told that in the last video also. If f is identity function, its inverse is itself. Right? Fx is f. F is identity function. F is identity function. Identity function. That implies f inverse is f. F is, if f is identity function, then inverse is itself. Same thing. Of is identity function. Of is identity function. Of is identity function. That implies f inverse is f. Self-invertible. F inverse is f. So I hope you understood, students. Let's move on to one more new concept, binary operations. Let us go for binary operations. Binary operations. One more concept, students. First, I explain short form BO. BO means binary operation. Binary operation. Students, look at this. We have these operations in our maths. Plus, the operation plus, we use that plus for addition purpose. We have one more operation, it is minus. We use it for a subtraction purpose. Next, multiplication operation. Next, division operation. Let us see. Now I explain how this becomes binary operations. Now I am going to explain how these operations becomes binary operations. Look at this. I take set of naturals. You take set of naturals. 1, 2, 3, 4, so on. I am taking set of natural students. I take plus. I take the operation plus. So let us think. Let us think under what condition this operation plus becomes binary operation. When this plus is taken as binary operation on the set n. Look at this, students. You do one thing. You operate this plus on any ordered pair. Look at this, students. I am operating plus on ordered pair 1, 2. I am operating plus on. You can operate this plus on any ordered pair of the elements of natural number. ಯಾವ ordered pair ಮೇಲೆ ಬೇಕಾದರೂ ಆಪರೇಟ್ ಮಾಡಿ. Plus of 2, 3. I take plus of 100, 101. I take plus of 8, 10. So similarly, you can operate. You operate this plus on any ordered pair of the numbers of natural numbers, right? We define plus of. We take plus of 1, 2. The meaning of this one is 1 plus 2. You should take plus of 1, 2 as what? 1 plus 2. Well, how much is 1 plus 2? 3. Is it a number of n? Yes. Next, you take plus. Plus of 2, 3 means 2 plus 3. Surely it is 5. Belongs to n. Next, plus of that is 100 plus 101. So how much it is? 201 belongs to n. So next, so right, tell me that 8 plus of 8, 10 means 8 plus 10, 18 belongs to n. So look at this students, how I write. I am taking plus ordered pairs n cross n. Tell me n cross n elements. 1, 1. Cross product, Cartesian product. You learned it in first year. 1, 1. 1, 2. 1, 2. 1, 3. So on. 2, 1. 2, 2. 2, 3, so on. This is n cross n. Now tell me how much is plus of 1, 1. Plus of 1, 1. 2. So right, you see this, students. 2, 3, 4, 5, 6, 7, right, so on. Right. Plus of 1, 1. Plus of 1, 1 means how much is plus of 1, 1? Plus of 1, 1 is equal to what? 1 plus 1 is equal to what? 2. Right? Plus of 1, 1. Plus relates 1, 1 with what? 2. Plus of 1, 2 means 1 plus 2, 3. Plus of 1, 3, 4. Plus of 2, 1. 2 1 3 plus of 2 2 4 so on. Is that plus a function, students? Yes. Here plus is behaving like what? Function. This type of functions are called as binary operations. Binary operations. So define binary operation. Binary operation. So this type of operations are called as binary operations. Look at this, students. So plus is a binary operation. Binary operation plus is a function from n cross n to n. 1, 2, 3. You take set of naturals. Set of naturals. Is it a function? Yes. Right? Binary operation plus is a function from n cross n to n. Plus is a binary operation. What about that? Into. Is that into a function, students? Into. Check that. Operate 1 into 1. 1 into 1 related to what? 1. Next. 1 into 2. 2 related to what? 2. We are getting 2. Into 1 into 3. 3 related to 3. 1 into 4. 2 into 1. 2 related to 2. Again into is a function. Minus. Is this minus a? Is it minus a function? Let us check. 1 minus 1. 0. Minus is not a function. When we say this as function, if it relates every element of first set with the elements of second set. Is it minus relating every element of first set? No. Minus is not a binary operation on n. Minus is not a binary operation on n. Right? What about divided by? It is not a BO because 1 divided by 1 belongs to 1 divided by 2, 1 by 2, 1 by 2, 1 by 2 related or not related? Not related. Not related. Failed in one subject means completely failed. It is not a function. I hope you understood. So define binary operation. Binary operation plus is a function from n cross n to n. So general definition. Now I explain general definition. So define. They are going to ask this definition for exam. By hand this definition. Define BO. Binary operation. Binary operation. Instead of taking plus minus into divided by, I take general operation. The general operation has star. I am taking general operation star. Instead of plus minus into divided by, here I am taking what? Star. Binary operation star is a function. From A cross A to A. In the place of n, I am taking what? General set. A cross A to A. Define binary operation. Binary operation star is a function from A cross A to A. I hope you understood. Let us stop this class, friends. We shall meet that in the next class. Thank you.